Okay, so this is part 2 video of our Systems of Inequalities application problem. We're talking about a girl Emma here, okay? If you didn't watch the previous video, make sure that you go back and do that now, otherwise this is going to be really confusing, okay? Now, in the previous video, we went through this word problem, okay, and we got our system of inequalities right over here, okay? So we got our system of inequalities. Now we need to go ahead and actually graph that so we can find different combinations of hours that she can work at each job, okay? The only thing we got to do is, well, when we graph it, we got to figure out what our scale has to be for the x and y axis, okay? We got to figure out what the scale is. Now we can go ahead and graph these and get them in slope-intercept form and use that to graph, but I'm actually going to go ahead and just find out what the x and y intercepts are for each of these. And that's going to help us figure out the largest x and y value we need to go to, and that's going to help us figure out what our scale is, okay? Now for this inequality, this is just going to be a vertical line with the x-intercept of 8, 0. That's just going to be a vertical line. Whenever it's x equals some number, that's just a vertical line, okay? Whenever it's y equals some number, or even inequality, if it's y equals some number, that's a horizontal line. So this is going to be a horizontal line with a y-intercept of 0, 12, okay? Now the reason that's important is I know now that I need to go to at least x, or excuse me, at least 8 for the x-axis, because that's my x-intercept, so I need to hit at least 8 so I can get the full visual of the graph. I need to go to at least 12 on the y-axis to hit my y-intercept for this inequality to get the full visual, okay? Now, what I do need to do, though, is get the x and y-intercepts for each of these inequalities so I can go ahead and see if they're larger and if I need to go a little bit further, okay? And actually, it's just going to make it graphing a lot easier because now we're just going to connect 2 points for each of these, okay? So, for this particular inequality, I can quickly find the x-intercept and the y-intercept by plugging in 0 for one variable, solving for the other variable, okay? So to find the x-intercept for this particular inequality, I'm going to do 15x plus 10y, but add an x-intercept, y is 0, so I'm plugging in 0 for y, is equal to 300, okay? And to find the y-intercept, I just do the exact opposite. I'm doing 15 times x, well, at a y-intercept, x is 0, so 15 times 0 plus 10y is equal to 300. Now, some may wonder why I changed the inequality symbol to an equal sign. That's because the intercept is a point on the line, okay? And all the points on the actual line come from the equation. The inequality just tells us pretty much where we're shading and if we connect our points with a solid or dashed line, okay? So that's where the inequality comes into play. But to find the actual points, we use the equation. Okay, so I'm going to find my x-intercept. I'm going to get 15x plus 10 times 0 is 0 is equal to 300. So I'm going to get x is equal to 20. So the x-intercept here is 20. And now I got to find my y-intercept. I do 15 times 0, which is just 0, plus 10y is equal to 300. So y is 30. So the y-intercept is 0, 30, okay? Now what this tells me is now the x-intercept, the largest x-intercept used to be 8, now it's 20, so I got to go to at least 20 down here, and the y-intercept is 30, so I got to go to at least 30 on here, okay? And then finally I can do the exact same thing for this inequality, and if you plug in 0 for y, solve for x, you're going to get an x-intercept of 30, 0. And if you do the same thing to find a y-intercept for this inequality, you're going to get another y-intercept of 0, 30. Okay, so what that means is I got to go to at least 30 for the x-axis and at least 30 for the y-axis, okay? Now, we have actually 15 kind of hash marks here, so I can't go by ones because I'd end at 15. I need to go to 30 for each, but I can actually go by twos. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and now I can hit that x-intercept of 30. I got to go to at least 30. I hit 30, and the same thing for y. I got to go to at least 30, so I can actually go by twos for the y-axis as well. I can go by 2's for the y-axis as well. So we have our x and y axis labeled, okay? And now what I can do is I can go ahead and actually sketch this graph, okay? So I'm going to go ahead and graph x greater than or equal to 8. That's going to be a vertical line when x is 8. And since this is greater than or equal to 8, I'd be shading to the right. X is greater than 8 at like 10, 15 and stuff like that, so I'll be shading to the right. And I'm just going to use arrows to signify where I'm shading so it doesn't get too messy. I got y greater than or equal to 12. Well, that's a perfectly, well, not too perfect, but it's supposed to be a perfectly horizontal line where y is 12, and we'd be shading up. We'd be shading above because it's when y is greater than or equal to 12. Well, that's at like 14 and 22 and 30, so I'll be shading above, okay? So that's the two easier ones out of the way. So we have those two inequalities, our vertical and horizontal line. Now we got to graph these two, okay? So for this one, we have an x-intercept of 20 and a y-intercept of 30, okay? And now what I'm going to go ahead and do is I'm just going to go ahead and do my best to connect these with a nice, solid, somewhat straight line. That was not too bad. I'm impressed with myself. All right, so I connected that with a solid line. All these were solid lines because it's or equal to with all these inequalities. If it wasn't an or equal to, it would be a dash line, okay? And since this is or equal to, I'd be shading above the line. So I'll be shading above the line. So as you can see, all my shading is starting to become in this region in here. So this region here is where my solutions are going to be so far. But I got one more inequality. I got x plus y is less than or equal to 30. I have an x-intercept of 30 and a y-intercept of 30. Okay, and what I'm going to do is I'm going to go ahead, I'm going to do my best to connect these with a nice straight line. And since this is less than or equal to, I would be shading below this line. This is less than or equal to, I'll be shading below this line, okay? And now what you see is that all the shading is going to overlap in this little region in here, okay? All the shading overlaps in this region here. So these are all the combinations of hours. These are all the combinations of hours that Emma can work, and work no more than 30 hours, but make at least $300, all right? Because that's what she wanted to do. She wanted to make at least $300. So now we can think about possible combinations. Well, she can work how many hours this is. This point here is, what is that, 12, 18. So she can work 12 hours as a nanny, 18 hours at the pet store. That's going to clear at least $300. But notice that's right at 30 hours, so she can make enough money in that particular case. She can work this many hours. So this was, let's see, that's 10. That's a point 10, comma 16. So she can work 10 hours as a nanny and 16 hours at the pet store, and she's going to clear at least $300, and she's still not working more than 30 hours. She can work, and since these are all solid lines, any points on these solid lines that bound a shaded region would work as well. So she could work, say, right here. She can work right here, which is 14 hours as a nanny and 12 hours as the pet store, and that's definitely less than 30 hours, but she would still clear $300, okay? So that's how a graph and a system of inequalities graph can help us find solutions to a situation, okay? So these are all combinations that she can work at each job, okay, where she's not going to work more than 30 hours, but she's still going to clear that $300 per week mark, okay? So that's systems of inequalities graphed with an application. Make sure that we're practicing this. Make sure that you're really reading the word problem and dissecting all that information correctly and forming your system with all of the information that they give you, okay? I hope this helps you out. In our next videos, we're going to be talking about actual systems of equations as opposed to inequalities, and they work fairly similar, okay, but a little bit different, okay? So make sure you check that out.